With a good understanding of the quality of service and quality of experience parameters at the application layer, now we shall enter the transport layer. As it is widely understood, the transport layer forms the heart of the end-to-end communication in multi-hop networks, whether wired or wireless. So we shall identify all the factors and performance parameters at the transport layer which would affect successful modeling and simulation in Omnet++ environment. For that, in this module, we should look at first all the transport services, and we'll carve out a modeling methodology that would help us to simulate. Transport layer, although is the second layer from the top in the TCP/IP stack, it is considered to be the big brother because on behalf of the application layer, it performs all the tasks. One of the central and most important activities the transport layer performs is it manages the successful delivery of data from the host to the other host. So, we are going to look at the services which transport layer provides either through TCP or UDP. And this overall functionality shall then be further explored with regards to implementation and simulation. One of the most obvious jobs of transport layer services has to be to multiplex and demultiplex data that is coming from various users. Likewise, the delivery of data from the source to the destination in a reliable and in order fashion is a requirement that transport services meet. When there is congestion in the intermediate network, that congestion, which usually builds up at the intermediate routers, is a network layer phenomenon, but it is dealt with at the transport layer in an end-to-end manner. If the receiving host does not have compatible and comparable features and facilities as the sender, it might get flooded with the traffic it cannot handle, so the problem of overflow arises. Transport layer services are implementing the flow control mechanism as well. And in order to emulate circuit switched behavior for the data traffic in the computer networks, connection establishment is a requirement. That too is one of the services offered by the transport layer. In contrast to the connection-oriented reliable services, UDP also provides services, but these services are with no frills and with no value addition. It is more akin to the best effort IP service with no guarantees on reliability, flow control, and congestion control. Whether we are using TCP or UDP, certain services are not available. These include: there is no bound on how much time is going to take to transfer the traffic between the two hosts. So no delay guarantees are provided. Likewise, there are no bandwidth guarantees as well, because both the TCP and UDP invoke the underlying connectionless network layer as IP network. So if there are no services provided by the IP network on both delay and bandwidth, so transport layer cannot assure any such thing. With all these services that we must explore and be sure about regarding their simulation and modeling, let's look at some of the parameters. These are very few of them that we might be interested in modeling. The first one is the overhead it takes to establish a connection between the two logical hosts at the transport layer. If multiplexing is one of the services at the transport layer, how much scalable is that? Efficiency at the transport layer is a natural thing to consider. The time it takes to establish the connection and also the time it takes to transfer the data Not that we have any control on the transfer of data, but the time it takes to transfer the data would also be worth considering. And we'd also be interested in knowing how much capability do we have at the transport layer to diagnose and combat congestion as a network layer phenomenon and overflow as an end host phenomenon.